We're told that the first derivative is the antiderivative of the second derivative. Um, I guess depending on where you are in your course, this might be the first time you're seeing this symbol, but the symbol is saying like this is a special operation you can do to get from like the acceleration to velocity. Oh, I don't know what that is. Okay, so we're supposed to find the first derivative, and they tell us that the first derivative is the antiderivative of x to the third minus 5x plus 9. In other words, this expression was the derivative of something. We took a derivative, we ended up with this. When you take derivatives with polynomials, we use the power rule, right? The power comes down, multiplies, and then it gets reduced by 1. This is the reverse power rule. We got to use x to the fourth power here. We got to use x to the second power here. And then we got to use, sorry about the dogs. We got to use x to the first power on this one. Okay, because when you take this derivative, well, it doesn't quite match, but at least the powers will line up. Now, the next step, before you say that this is the antiderivative, we can't say this is equal yet. And close, though, the powers are right. We have to put a 1/4 out front, because when you take the derivative, the 4 comes down and multiplies to this 1/4 to cancel out and make just x to the third. Right now, if we take a derivative of this term, it makes x to the third, so we're good there. If you take a derivative of this term, though, it's not going to make just 5x. It's going to make minus 10x. We got to compensate by dividing by 2. That way, when the 2 comes down, multiplies. When we take the derivative, it'll turn to this. This one's all set. If you take the derivative of 9x, you get 9. So this is our antiderivative. So that's what we want to type into the first part. 1/4 x to the fourth minus 5/2 x squared plus 9x. And then the last thing I left out was plus a constant c, because look, this expression, when you take the derivative, would be equal to this, because the derivative of a constant is nothing. This expression would also have the same derivative. This constant could be any plain old number. Okay, I think I have to hit submit, and then it'll show me the next part. And then it says we're supposed to find the derivative of f at 1 in terms of c sub 1. So this notation says plug 1 into your first derivative. Remember, this is our first derivative because this was our second derivative. So first derivative at x equals 1 is just 1/4 minus 5/2 plus 9, because 1 times 9. And then this is plus that arbitrary constant c that we were talking about. So it wants us to leave that c in there. So to finish out this problem, to finish out what it is in terms of 1, I just want to get common denominators. 1/4 minus 10/4 plus 36/4 plus that constant c. So that's going to be negative 10 plus 36 is 26, 27/4 plus that constant c. Okay, we said 27/4 plus the constant c, and then to get that subscript, it's not in these usual buttons. I'm going to hold shift and press the minus key. That gets me a subscript, so I think that's what they're looking for there. That's f sub 1 in terms of c sub 1. And then they're saying thus, the derivative of f sub 1 equals 0 corresponds to c sub 1 equals 1. That's a bunch of math language that says, hey, if you were to plug in 0 in for the first derivative, what we just did over here, if you plug in 0, you can solve for c now, c sub 1. Okay, so if you do that, you get c sub 1 equals negative 27/4. Solve that equation by plugging in 0 into the left side. You get negative 27/4. They want a decimal. They're not letting me type stuff in there, so I'm going to assume I want negative 6.75, but we'll see. It'll tell us if we're wrong. Using this value of c sub 1, they want us to restate the derivative. The derivative up here is 1/4 x to the fourth minus 5/2 x squared plus 9x, and then we subtract it by 27/4, because that was what we got for c sub 1. Let's see if it liked that decimal answer. It did. I don't know why they're having us type fractions up here, decimals over here, but we'll move on. Now they say, hey, this is the first derivative. Find the original function. So we need another antiderivative. So if we go back to the drawing board here, this is our first derivative is this. And so to find the original function f of x, we're doing the same thing. We're using our imagination to picture what the other function should be. So x to the fifth, we got x to the third. Because I'm looking at these powers and I'm bumping them up by 1. Because I'm trying to imagine what the function was before we found this derivative. And the power rule means the powers are getting reduced every time. 27 over 4 is going to have an x next to it, and then we have a new constant. We'll call it c sub 2. I don't know what WebAssign wants. But look, this isn't quite the right derivative. Antiderivative. This isn't quite the right antiderivative, because if you take a derivative of this, it doesn't make 1/4 x to the fourth. We need 1/4 to happen. So that's why I'm going to put a 1/5 and multiply. In other words, 1 out of 20. Because 5 times 1 out of 20 makes 1/4. And now this term matches up. Same thing over here. We want it so that if we take the derivative of this term, it turns into this term. So we need to have a 3 multiplying on bottom. So 5 over 6. And you can check me. If you take a derivative of this term, it should be minus 5/2 x squared. Same thing here. We want it to be a 9 as a constant, so I'm going to put that under 2. Everything else is good. Because you take a derivative of this term, it does make minus 27 over 4. And then we need that arbitrary constant c. I got to type all that in. There's minus 27 for x. Then what do they want for a constant? Oh, they already typed the constant c sub 2 for us. Okay, so we don't need to type a constant. And then they want you to do the same thing. Plug in 1 in here. I'm going to try to do some quick fraction work, but we're plugging in 1 everywhere where we see an x. Oh, man, that's just so much fraction, so little calculus. The common denominators are brutal here. Because the 6, you got to have everything in terms of 20. Okay, so we're plugging in 1. If I plug in 1 everywhere, we just get the coefficients. And if I get common denominators, the least common denominator I think is 60. So this is 3. Over 60. And then this is the 6 on the bottom. That's going to multiply the top and the bottom by 10. So that's 50 over 60. And then here, that's multiply the top and the bottom by 30. It's 270 over 60. And then what do we have to do there? Top and the bottom by 15. So 405 over 60. And then if we add all the numerators, 270 subtracted by 405, subtracted by 50 plus 3. I got negative 182 over 60. And now I'll reduce that. I got negative 91 over 30. Okay, but this still plus that constant c sub 2 out here, right? We haven't taken care of that. So negative 91 over 30 plus c, and then I'm hitting shift and the minus key to get that subscript. And then they're saying, hey, if you plug in 4 into the left side, what's that going to equal? You're going to have to add that 91 over 30 to both sides, so great. More big fractions, because hard to get common denominators there. We need 60 as a common denominator, so let's actually just go back here, and then 4 times 60, that's 240. So I got 240 over 60 equals negative 182 over 60. I went back to this one because we're trying to get common denominators. Oh, I could have got, no, I don't need to use that. You might have been wondering what I was doing there. It's just too much going on. So this is -4 equals -91 over 30 plus c sub 2. To get common denominators, we need to multiply the top and the bottom of this fraction by 30. So that's 120 over 30 equals -91 over 30 plus c sub 2. So add that 91 over 30 to both sides. We got 211 over 30 equals c sub 2. Oh, they want a decimal again. It doesn't come out to a nice clean decimal, so that makes me think I did something wrong. It's going to take a lot of work to go back and check this. I'm just checking to see if I messed something up. No. 182. No, it looks like my fraction work was right. I mean, the WebAssign doesn't specify the decimal, but they're asking for a decimal answer here. So 211 over 30, I think, is what we got. 7.033. And then we found f of x. They would just want us to rewrite f of x. Was it negative though? No, it's positive 211 over 30. Okay. Okay, I have a feeling it's going to be wrong because of that decimal. Yeah, it says I got 7 out of 8, right? I don't know what they're looking for. I mean, if it's 7 out of 8, that means either this or this is right. If I skip, maybe it'll tell us. No, those are all the answers I gave. So maybe we just have to carry the decimals out. But if you're in my class, when I look over your homework, when I transfer grades, if I see something like this, it's marked wrong because you didn't carry out the decimals when they don't tell you how many decimals. And don't worry about it. I'll give you credit for that.